Every now and then, we hear that astronomers have discovered a new planet, a distant world that might have the right conditions for life, a so-called second Earth. At first, the idea is thrilling. There could be oceans beneath its clouds, unfamiliar forest, exotic animals, or even an intelligent civilization looking back at the stars. For a moment, it feels as though we may finally have discovered another living world. But then, one number appears near the end of the article, and the excitement suddenly fades. 100 light-years. On the scale of the Milky Way, 100 light-years is relatively close, but for humanity, it is an almost unimaginable distance. 1 light-year is the distance light travels in an entire year, roughly 9.46 trillion kilometers. The distance is so enormous that calculating the journey by car is pointless. Even at the speed of a passenger jet, the journey would take so long that the number would become practically meaningless. And even Proxima Centauri b, one of the closest potentially habitable exoplanets we know of, is more than 4 light-years away. It takes light itself over 4 years just to reach it. The Parker Solar Probe holds the speed record for a human-made object. At its peak, it traveled at roughly 690,000 kilometers per hour. That sounds unbelievably fast, but even if a spacecraft could somehow maintain that speed for the entire journey, it would still take roughly 6,600 years to reach Proxima Centauri. Every time we discover another world, we hit the exact same wall. We can find it, we can observe it, but we cannot go there. And that raises a strange question. If humanity cannot reach a planet just a few light years away, how could alien visitors possibly reach Earth? How could any civilization cross tens, hundreds, or even thousands of light years? How could anything survive a journey across such an enormous distance? Before we go any further, this script is not claiming that aliens have actually visited Earth. There is currently no scientific evidence that extraterrestrial beings have visited our planet. This is a thought experiment. If an advanced alien civilization did reach Earth, how might it have done it? And as we explore those possibilities, we may discover that aliens would not have needed to travel faster than light at all. First, imagine a familiar scene from science fiction. A massive alien spacecraft activates its engines. The stars stretch into long trails of light. The ship accelerates to the speed of light, and seconds later, it appears near Earth. It looks spectacular, but according to our current understanding of physics, that simply cannot happen. Light has no rest mass. That is why it can travel through a vacuum at nearly 300,000 kilometers per second. But aliens have mass. Their spacecraft have mass. Their fuel has mass. And the closer an object with mass gets to the speed of light, the more energy is required to accelerate it. The energy requirement does not simply become enormous, it keeps rising without limit. To accelerate an object with mass to the exact speed of light would require an infinite amount of energy. No matter how advanced a civilization becomes, it cannot draw on an infinite supply of energy. So according to Einstein's theory of relativity, a physical spacecraft can never reach the exact speed of light. But what if it traveled almost as fast as light? What if an alien civilization could accelerate a spacecraft to 90% of the speed of light? At that speed, a journey from Proxima Centauri to Earth would take about 4.7 years from our perspective. But something very strange would happen inside the spacecraft. For the travelers on board, only around 2 years would pass. This happens because time behaves differently for objects moving at extremely high speeds. The closer a spacecraft gets to the speed of light, the more slowly time passes for the travelers inside it, compared with people who remain on Earth. This effect is known as time dilation. Now, imagine something even more extreme. Suppose an alien spacecraft traveled from the TRAPPIST-1 system about 40 light-years away at 99% of the speed of light. From Earth's perspective, the journey would take a little over 40 years. But for the travelers on board, the trip would feel closer to 6 years. This simplified calculation does not include the time needed to accelerate and decelerate, but it reveals something important. A journey that lasts decades for observers on Earth may feel much shorter to the people inside the ship. Aliens would not need to move faster than light to dramatically reduce the amount of time they personally experience. However, there is a terrifying problem. The spacecraft would be moving incredibly fast. Why is speed itself so dangerous? because space is not truly empty. It contains scattered hydrogen atoms, microscopic dust particles, and fragments of rock. At ordinary speeds, a tiny piece of dust seems harmless, but at a significant fraction of the speed of light, even microscopic debris becomes an explosive projectile. Imagine a spacecraft traveling at 20% of the speed of light. If it struck a dust particle weighing only 1 milligram, the collision would release energy comparable to roughly 4/10 of a ton of TNT. A single grain of dust could tear right through the front of the ship, and the spacecraft would not encounter just one particle. It would spend years traveling through an invisible ocean of debris. An alien civilization attempting such a journey would need extraordinary protection. It would need a propulsion system capable of producing unimaginable amounts of energy, a way to slow down after reaching its destination, and a way to protect its passengers from radiation, high-energy particles, and repeated impacts throughout the voyage. If aliens reached Earth at near-light speed, their greatest technological achievement might not have been the engine. It might have been the spacecraft's ability to survive the trip. Now, let us turn the entire idea upside down. Whenever we imagine aliens visiting Earth, we usually picture biological beings sitting inside a spacecraft. But why would they need to come in person? Humanity already follows the same logic when exploring our own solar system. Before sending humans to Mars, we sent robotic probes. We sent machines to Venus, Jupiter, Saturn, and the outer reaches of the solar system. When a destination is too distant or dangerous for living beings, we send machines first. An alien civilization may have made the very same decision. Perhaps the object that reached Earth was not carrying biological aliens at all. Perhaps it was an autonomous probe guided by artificial intelligence. A robotic probe does not need oxygen. It does not need food. It does not get lonely, and it does not grow old. It does not need to raise children or support an entire population during the journey. As long as its systems function, it could travel for hundreds, thousands, or even millions of years. An alien civilization might not launch just one enormous spacecraft. Instead, it could release thousands or even millions of tiny robotic probes into the galaxy. Some would collide with dust and be destroyed. Some would lose power. Others would miss their targets completely. But if even one probe survived long enough to reach Earth, the mission would be a success. Now imagine that the probe could harvest resources found at its destination. It might collect metals from asteroids or gather energy from a nearby star. It could repair damaged components, build new instruments, or even create copies of itself. One probe could reach a new star system, build several more probes, and send them toward neighboring stars. Those probes could then repeat the process. The civilization that launched the original machine would not need to travel across the galaxy personally. It would only need to create a machine capable of continuing the mission on its own. Over time, these probes could spread from star system to star system, like mechanical seeds scattered across the Milky Way. And there is an even stranger possibility. The civilization that originally created those probes may no longer exist. It could have disappeared hundreds of thousands of years ago. Its home planet might now be lifeless. Its cities turned to dust. Yet the machines could still be traveling, still following their original instructions, and still searching for living worlds long after their creators vanished. The first alien intelligence humanity encounters may not be biological. It may be an ancient machine whose creators have been dead for 1,000,000 years. There is another assumption we often make. We think about time strictly from a human perspective. To us, 1,000 years feels almost eternal. No individual human can survive for that long. Governments rise and fall, languages transform, and entire civilizations disappear. So, when we hear that an interstellar journey could take several thousand years, we automatically label it as impossible. But that is a human timeline. The universe does not operate according to the length of a human life. What if an alien species lived for 10,000 years? A 500-year journey would represent only 5% of its lifespan. For a human living 80 years, that would be comparable to a journey lasting just 4 years. Long, but entirely manageable. To us, 500 years spans many generations. To them, it could be a single expedition completed within one lifetime. There is no law of nature requiring intelligent extraterrestrial life to share our lifespan. Alien biology could operate much more slowly. Their cells might repair damage far more effectively. They might replace biological organs with machines, suspend their metabolism for centuries, or simply not experience aging as we know it. The journey only appears impossible when we assume the travelers are fragile, short-lived creatures like us. Now, consider an alien civilization that began developing technology 1 million years before humanity. 1 million years sounds like an unimaginable amount of time, but compared with the age of the universe, it is remarkably small. If the entire history of the universe were compressed into a single 24-hour day, 1 million years would equal only about 6 seconds. In cosmic terms, that civilization appeared just 6 seconds before us. Yet the technological gap could be beyond anything we can comprehend. Humanity went from the early industrial revolution to nuclear energy, space travel, artificial intelligence, and planetary exploration in just a few centuries. Our modern technological civilization is still extraordinarily young. Imagine what another civilization could achieve with an additional 1,000 years of progress, or 10,000, 100,000, or 1 million years. Their technology would not simply be an upgraded version of ours. It might operate on principles we have yet to discover. It could be so advanced that we would not even recognize it as technology. If an alien probe reached Earth, it might have begun its journey long before humans existed. It may have been launched when early mammals were still small creatures living in the shadows of dinosaurs, or when complex life on Earth was just beginning. When the aliens first studied our planet, they would not have seen cities, satellites, or radio signals. They might have detected oxygen in Earth's atmosphere, liquid water on the surface, or chemical signatures suggesting life. They would not have sent a probe to meet humanity. They may have sent it simply to investigate a living planet. And by the time the probe finally arrived, we just happened to be here. But what if the visitors were not machines? What if biological aliens came here in person? Every method we have discussed so far still takes time. So, is there any way to cross tens of light years in a matter of days or hours? This is where the concept of a wormhole comes into play. Imagine drawing 2 points on a sheet of paper. One point represents the alien planet. The other represents Earth. If you travel across the surface of the paper, the 2 points are far apart. But what if you fold the paper until the 2 points touch? Then you could punch a hole directly through both layers. Instead of traveling across the entire distance, you pass right through from one point to the other. A wormhole is a hypothetical shortcut connecting two distant regions of space-time. A spacecraft would not need to race across the universe faster than light. It would simply take a much shorter path. In theory, Einstein's general theory of relativity allows physicists to study space-time structures like wormholes. However, keeping a wormhole open would require exotic forms of matter or energy that we do not know how to produce. We do not know whether a large, stable, traversable wormhole can even exist, and humanity has never discovered or created one. There is another problem that is rarely discussed. A wormhole requires an entrance and an exit. One end might exist near the alien civilization, but the other end would need to be located near Earth. How would it get here? Unless the wormhole formed naturally, someone would have had to transport one end of it to our solar system using conventional, slower-than-light travel. That means even a civilization capable of using wormholes may have needed to cross interstellar space the slow way at least once. From our current perspective, this seems almost impossible. But if an alien civilization were hundreds of thousands or millions of years ahead of us, it might have learned to manipulate space-time in ways we cannot yet fathom. Still, we should be careful. Just because something can be described mathematically does not mean it exists in reality. Wormholes remain purely theoretical, but when discussing a civilization vastly more advanced than ours, it would be premature to assume today's human technology represents the ultimate limit of what is possible. There is another possibility. We often assume aliens must come from a planet hundreds of light years away. But what if they came from somewhere much closer? There are no known stars within 1 light year of the Sun, and the nearest known star system is over 4 light years away. But even if an artificial object were located just 1 light year from Earth, it would be extraordinarily difficult for us to detect. Could we spot an alien satellite or space station at that distance? In most cases, no. Earth is roughly 12,700 kilometers across. While the International Space Station is only about 100 meters wide, Earth is more than 100,000 times wider than a structure of that size. At a distance of 1 light year, detecting an ordinary artificial object would be practically impossible with current technology. We already struggle to directly photograph Earth-sized planets around other stars. A small spacecraft nearby would be completely drowned out by the glare of its host star. And that leads to an even more unsettling thought. What if an alien probe is already inside our solar system? It would not need to land in a major city or hover over a military base. It could sit quietly near an asteroid, observing Earth from a distance. It could hide in a gravitationally stable region, remain extremely small, and collect our radio signals without transmitting anything powerful enough for us to detect. There is no evidence that such a probe exists, but if its mission were pure observation, why would it reveal itself? When human scientists study wild animals, we do not park a helicopter directly above them. We hide cameras, maintain our distance, and observe without interfering. An advanced alien civilization might treat Earth in the exact same way. The most successful observation probe would not be the one we discover. It would be the one we never notice. So let us return to our original question. How could aliens reach Earth without traveling faster than light? Perhaps the answer is simpler than we think. Maybe they did not need to travel fast at all. They may have crossed the cosmos slowly on a journey lasting centuries or millennia. They may have sent artificial intelligence instead of biological passengers. They may have launched their probes millions of years before humanity ever appeared. Or they might live so much longer than we do that a journey we consider impossible feels like a routine trip to them. Alternatively, if they possess technology far beyond our comprehension, they may have learned to shorten the distance itself rather than increase their speed. And perhaps at this very moment, somewhere within our solar system, a small machine is drifting silently through the dark, a machine that crossed interstellar space over thousands of years. It produces no visible light, transmits no obvious signal, and makes no attempt to interfere. It simply watches. It watches a small blue planet as its cities expand, its satellites fill the sky, and its inhabitants slowly begin searching the cosmos for signs of other life. Maybe the reason we have not found alien visitors is not that they are too far away. Maybe they are simply too small, too quiet, and too advanced for us to recognize. If aliens have reached Earth, they may not have needed to travel faster than light. They may have simply left earlier, waited longer, or realized that the greatest obstacle to interstellar travel is not distance. It is the short lifespan of the traveler. Perhaps the real secret to crossing the stars is not speed at all. It is building something that can endure for thousands of years, something patient enough to keep traveling long after its creators are gone. And one day, when humanity finally sends its own machines to another star, we may finally understand. The universe was never impossible to cross. We were simply measuring the journey with a human clock.